Hello everyone, I am Manvi Tandon and I am going to get you all acquainted with my presentation topic, which is Artificial Neural Network, abbreviated as ANN, bridging the gap between humans and machines. We will be talking about these topics starting from the introduction to ANNs, the analogy, components, training and applications. We will talk about current challenges and limitations, and finally, we will come to future prospects. So, what is ANN? ANN are models inspired by structure and function of our human brain. ANN is used in machine learning and artificial intelligence to process and analyze complex data, particularly tasks involving such as pattern recognition, classification, and prediction. So let's take an example. Here we have a picture of a biological neural network and artificial neural network. By seeing these pictures, we can conclude by looking that dendrites in biological neural networks is the input in artificial neural network. Cell nucleus is represented as nodes, synapse is the weight, and axon represents the output. Just like a brain that can recognize patterns and make decisions and learn from data, ANN performs similar tasks. There are various types of ANN, such as feed-forward neural networks, recurrent neural networks, convolutional neural networks, we usually call it as CNN, and radial basis function networks. Now, talking about the components of ANN, we have input layer, which receives and transmits the raw data or signals into the neural network. Weights and biases adjust the input values, and activation function enables the model to work on complex data. And output layer represents the final result. Now, when we talk about training of ANN, training data is the foundation of artificial neural network. If there is no data set, we wouldn't be able to recognize patterns and make predictions. So, it is done by three things: supervised learning, backpropagation algorithm, and activation functions. Obviously, ANN have made reasonable and remarkable strides in various fields, for example, image recognition and computer vision, natural language processing, autonomous vehicles, and especially in healthcare. But despite its potential, ANN face many challenges also, such as overfitting and underfitting, data limitations, computational resources, interpretability, and transparency. Now, if we talk about overfitting and underfitting, overfitting occurs when model captures noise, and whereas underfitting occurs when the model is too simple. When we talk about computational resources, we can say that some data set require more power, more high tech components. So challenges is computational resources that time. In addition to challenges, ANN also have limitations. For example, complex architectures that require large data sets, lack of generalization in some scenarios, vulnerability to adversarial attacks. Now, when we talk about vulnerability to adversarial attacks, what happens is that the input alterations lead to misclassification and wrong outputs. Ethical concerns. Talking about ethical concerns, these consideration only arises due to the biases present in training data, which also leads to the unfair outcomes. Now, the main reason I chose the topic is to make people aware about what future prospects this ANN holds. So, say about explainable AI, which is the most popular term used right now. We use chat GPTs. So it focus on developing systems that provide us clear and understandable explanations. Now we have talked about the ethical concerns and evolving these regulations to address issues like bias, fairness, and privacy is important in today's AI development and deployment. And new domains, new applications are coming each and every day. For example, space exploration and other scientific endeavors. So we can conclude that this presentation um, is is talking about ANNs, and ANNs are the powerful tool that are still evolving. And as the subtitles said, It holds the potential to bridge the gap between humans and machines, offering solution to complex problems. Thank you. Have a nice day.